y is equal to f prime x, where f is a cubic function, is sketched below. Okay, so there they give us the graph of f prime x. Okay, and as you can see, it's as you might know, a sad face, and it's just a parabola, and they base questions on that. So using your graph, they say, answer the following question. So 10.1 is, for which values of x is the graph of y is equal to f prime x decreasing? Okay, once again for this, you need to know your theory behind calculus. So when a graph is decreasing, we solve, in our case, for f prime x, based on our theory, it should be greater than 0. Okay, but then we're dealing with a parabola here. So we find out where our midpoint is, and then we solve for that. Okay, in other words, our midpoint there, where it's our turning point, is based on what we're given. You can only calculate that using the two positions they give us, the -4 and the 1, which both lie on the x-axis. So they both are like, you can use that as your reference point. If you add those two up and divide by 2, you will get the actual midpoint between those two lines, which will give you your turning point. So what I mean by that is, I'll say turning point, it should equal -4 plus 1 all over 2. Okay. In actual fact, yeah, it should be -4 plus 1 all over 2. Then you just solve for that, it should be -3 over 2. And that would be your turning point. That's the x value. And then what we're saying, this is the value of f prime x, right? At that point. So it should be, at that point, f prime x should be greater than 0. Therefore, if you've got this point as x minus 3 over 2 being a turning point, at that point, like everything that's to the right of it, in other words, just substituting for that, x at any point x greater than -3 over 2, based on this theory, should give you the value for x for which this graph is decreasing. Okay, so based on this, we'll base everything to that midpoint value of x. Okay, and then using the same knowledge, we're going to tackle 10.2. So 10.2 says, at which value of x does the graph of f have a local minimum? Give reasons for your answer. Okay, at which value of x does the graph of f have a local minimum? Okay, so in order to do this, you can either solve for, you have to solve for the part which is less than -4. In other words, looking at your graph, you've got the part which is x is less than -4. Then you've also got the part where x is between -4 and 1. And you've also got the part where x is greater than 1. So you need to check where all these points, like what's happening at all those 3 points, those 3 intervals rather, and see where your local minimum might lie. Okay. Okay. And looking at your question, f prime x at x is equal at x is less than -4. F prime x will be, what is it? Less than 0. Can you see that? Let me draw it for you. Right. So quickly looking at your curve, you've got that. Okay. This curve here we're referring to as f prime x. This point here is -4. This point here is 1. That's your y, that's your x. Can you see? Where is f prime x less than 0? It's, let's look at -4. It is this part. That's where it's below, right? Let's test now between -4 and 1. Clearly for -4 and 1, f prime x is what? Greater than 0. Okay? And lastly, if you check the last one, where x is greater than 1, that would also be a point where f prime x is less than 0. Okay. But then the actual local minimum based on the 2 points would be in -4, because that's the minimum value of f prime x. So your final solution, you would choose x is less than -4. Okay. Without further ado, we'll move on to question 11.
Okay, question 11. Now here comes the most simplest question. Well, question 11. It's a common sense question. Why? Check. It says water is flowing into a tank at a rate of 5 liters per minute. At the same time, water flows out of the tank at a rate of k liters per minute. The volume in liters of water in the tank at time t in minutes is given by the formula. Alright, now we are told that the volume at any given time, right, is given by this formula. Vt is equal to 100 minus 4t. Alright, now volume at any given time, alright, is this. Now the question is saying 11.1. Right. Okay, what is the initial volume of the water in the tank? When you are saying what is the initial, what are we talking about? Before the water flows in and out. At the beginning. Remember, initial time is t0. Alright, at the beginning. Okay, so now initial time is just V. That's why they say what is the initial time. So V0 is equal to 100 minus 4t. So initial volume liters. That's why I say it's common sense. Okay? That's why I say it's common sense. What is the initial volume of water in the tank? What was it? At time 0. So you just put wherever there is t, you put 0. Then it becomes, okay, 0 here. And then this is 0. Then done. 100 minus 0. Okay?
Or maybe if they use 5 seconds, and then when you see t, that's what you're going to substitute by 5 seconds.
Yes. If there was volume at time, 5 seconds, so wherever there is t, you are putting 5. So it will be 100 minus 4 times 5. Okay? Alright, now 11.2. I write down 2 different expressions for the rate of change of the volume of water in the tank. 2 different expressions for the rate of change of the volume of water in the tank. We're talking of the rate of change. Now, rate of change there. Okay, we are given that the rate of 5 liters per in. So we can just say inflow minus outflow. Or rate in minus rate out. What was the rate in? 5 liters. Minus rate out? K liters. That's it. That's why they say write down. So that's it. Now the rate, look at what the question is, rate of change. So it's what? Now we're answering the question. The rate of change is rate of change is equal to 5 minus k liters per minute. Alright? 5 minus k liters per minute. That is the rate of change of the volume of water. This is first one. Remember, there are two expressions. Now, the other one, remember, Vt, the rate, the volume at T. So we can use also that one. The rate of change will be, this is 1, this is 2. Remember, two different expressions. Now 2, it will be V at time T. What is it? Derivative of this one. What are we going to get? Minus 4. What? That's it. So these are the two expressions. Remember, rate of change is derivative also. Right? So that's what they want. So when you have done that, write down. That's why they write down. It's very quick and simple. Is it clear?
Yes.
Okay? Let's keep this in mind. Now it says now, determine the value of K. That is the rate at which water flows out of the tank. Alright. Now, this water is flowing out of the tank. Now remember, we can say 11.3. Okay, the volume of the water at given time. Volume at any given time, right, is called the initial, all right, the initial water that was there in the tank plus the what? Inflow minus, when we are saying outflow, we are talking of the one that is going out. Inflow, the one that is getting in. Alright, so volume of water at any given time, what was it? 100 minus 4t, right, is equal to initial volume. How much was it? Initial? That's it, 100%. 100 liters. Now, plus inflow. Okay, but now it's 5 liters per. That's it. And then outflow. K. K. T. Alright. Is it clear? The one that we have, volume at any given time is given by this. Now, initial 100, inflow is 5t because it's 5 liters per minute. And then K liter per minute. Alright? Then we solve for. Remember, we have to determine the value of K. The rate at which water flows out of the tank. Alright? So what I'm going to have there? This and this one, what is going to happen? So we're going to remain with what are we going to remain with? Okay. 100 minus is equal to K T. Alright. And then what are we going to get?
No.
Okay? What are we looking for?
Okay.
Determine the value of K. That is the rate at which water flows out of the tank. So it's 9.
So, is it 9 liters per minute? Or
Yes.
it's just 9?
Yes, it's 9 liters per minute. It's fine.
But since here it said we must look for the value of K, would it be necessary for us to see per minute or just leave it the way it is at this?
Okay, but if it's K, it's fine like that. Because K says K liters. So it's 9 liters. Alright? Okay? Now another formula again that we can work it out. Remember those two things, two expressions that we used to get the rate of? These ones. The first one was 5. This one 5 minus K, and the other one was minus 4. Now we can just equate the two. This is another alternative way of working out. Alternative. Remember it was K minus 5 minus K. It's 5 minus K is called. So maybe we say K is called simple one. So this is an alternative method. We have to determine the value of K. Alright. Any question on this one?
So, if you use the second method, are you still going to get the same marks?
4 marks.
Okay.
4 2 marks. You just choose the one that is more simpler for you. No, this one is good because you can be able to analyze to say, okay, at any given time we put this, the initial we had 100, and then the inflow is 5 liters per minute, and then K per minute, and then you play around to get your answer. Alright?
One more thing which I wanted to ask is that the formula that we use, like when we given like is initial plus inflow minus outflow.
Yes, you get the formula where you get it. That's why I say it's, remember at the beginning, I say it's common sense. Remember water? First of all, there was water. And then the other one is coming, and the other one is going out. But we are given that volume, like the expression for volume V as a function of T, or volume at a given time, is called 100 minus 40. That's what you are told, that the volume at any given time is going to be 100 minus 40. Then you play around with the initial, the one that was there at first, plus the one that is inflow, that is getting in, minus outflow, what is going out. So at any given time, they should always balance. Because this one means that there was something plus, so you should get your K from there. Alright. So now let's do the last question, question number 12. Question 12. It says there, a school is planning a trip for 500 learners. The company that will be providing the transport has two types of buses, red buses and blue buses available. Now each red bus has 50 seats and each blue has 25 seats. The company has at most 50 bus drivers available. Scroll down. And then there are at most 8 blue buses available. Alright. Now, let the number of red buses hired by the school be X. Now we are told red, we are going to put X, and then blue, Y. Remember, don't make your own question. Don't make your own variables. You are told, follow that. Okay, now it says there. Now let the number of red buses hired by the school be X and the number of blue buses hired by the school be Y. Now, write down all the constraints in terms of X and Y to represent the above information. Now, check on those 3 conditions that you are given. That's the constraint that you are given. Now you need to express them in terms of inequality. That's the constraint. Don't put equal sign on there. Now it says that each red bus has 50 seats. But we don't know how many red buses are going to be there. That's why we represent by X. So each red bus has got how many?
6.
Then, and each blue bus is 25 seats plus 25 1. But all these, you want to say something? Okay, 50 x 25 1. But all this should be able to accommodate how many learners? 500 learners. So all this should be able to accommodate. That's why it should be greater or equal to 500. It cannot be less than, because if it's less than, which means it cannot accommodate these students. Alright? It should not be equal to, but it should be greater or equal to 500. Alright? That's the first constraint. We're talking of constraint. Constraints. Now, 2. The company has at most 15 bus drivers available. The company is at most how many?
15 bus drivers.
So whether this driver is going to be an X and is going to be on Y, but they should be at most. When you hear the word at most, it should mean it's 50 and less. So it's going to be less or equal to 15. That's it. Now there are at most 8 blue buses. This is third one. At most 8 blue buses. So which blue is one? At most 8 blue buses. Done. You get all your full marks. This is what we call the constraints in terms of x. Done. Alright. So now we are covered with question 12.1. Okay, these are the constraints. Now let's do 12.2. Now 12.2 says represent the constraints graphically on the attached diagram sheet. Clearly indicate the physical region. Alright. Now what we need to do from this one, we are told that this one, and this one, these are the 3 things that we need to do, okay? Now it says, so we need to represent all this information on the diagram sheet or on the graph. Alright. Let me use this other side. But that information you don't need to delete it because you are going to use it again. So 12.2, we draw now why we use the blue ones, eh? So we call blue buses here, and then the other ones gray. Alright, so now on this board we're just going to draw the necessary points or the points that we need. Alright, now this is 0. Okay, but we can just going to use the one that they use 1 up to 30 according to the graph, and also the 1 up to 22. Okay, so now what you need to take note of is this. Remember, we are drawing those constraints. Now we are representing them graphically. Now, just when you are representing them graphically, just forget about this less or equal to sign or inequalities. Just say is equal to, right? And then you draw those linear lines. All right. So let's start with this simple one. Y is equal to 8. All right. How do you draw it? Now you come here. They just say 2, 4, 6, 10, 16, 8, 22. So it's 2, 2, 2, 2, 2 going up. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, right? So now we are saying 8, eh? So which means our line is going to be this one. Alright? That's the line. He said I can label it. Sometimes you can maybe say this is 3, since we use 3 there, so that you can be able to see which is which. Okay, let's just say 1, 2, 3 there. And then this other one now, x plus y is equal to 15. Alright, how do you draw it? It's very simple. Remember I said x plus y is equal to 15. So when you are drawing them, just say when x is equal to 0, what is y? Okay, let's just leave it there. And then now we are saying when x is equal to 0, what is y? It's called 15, isn't it? Okay? So when x equals 0, y is 15. 15 is somewhere here. And then when y is equal to 0, what is x? 15 again, somewhere here. And then we join these two lines. These 2 points are together. Like that. Okay? So this is our second. Let's just label it 2. Okay? Now let's do the final one. This one. We do the same process again. 50x plus 25y is equal to 500. Alright? Now, if x is equal to 0, what is y? This will become, let me do it here. If x is equal to 0, then 25y is equal to 500. Y is equal to 20. Okay, that's it. So y is going to be this point. And then when y is equal to 0, what is x? When y is equal to 0 now? 500 divided by 10, isn't it? Alright. And then this is going to be the point. So we load these points like that. Okay. So we've drawn, this is like our first, so that we can be able to see which is which. Now, we have represented these constraints graphically. But now, remember, we need to indicate the feasible region. How do you determine, what do you use to determine the feasible region? We are going to use these inequalities. Remember, when you are looking at constraints, use the inequalities. Now, when you are representing them, just forget about this symbol, just put it outside and you draw your linear or lines. That's why it's called linear programming. It's about lines. And then when you have done that, and then now we are talking of feasible region. So first of all, remember, let's look at this one. It says greater or equal to 500, which means whatever the graph that we have drawn should be positive. Okay? So we go to this graph, this line, sorry, that we've drawn, this one. So this region that we are talking about, I'm going to use different markers here. Alright? So that what I'm explaining. So we are looking at this region. Okay? But I'm going to erase later on. Now the second one, so this is greater part, the positive one. Okay? Now let's look at this one. Less than 15. Okay? Now we go to that line, it's 2. This one. So it's less than. So we are going to this is the region of this line. Alright? Now we go to the final one. It's less than 8. Now we go to this graph. This is the one for 8, right? Now the less than is this one. Now the feasible region is the region where all these these regions have been meeting. Not here, not here, not here, but not here again, not here, but it's here. Alright? So this is the region, the feasible region that you need to operate. That's why I said now, let me erase all this. Have you seen how you get the feasible region? Okay. So when you have shaded there, you get your full marks now. So this region there, this thing is the feasible region. This, you can even write this far. Okay, that's it. So we're done with that one. Alright, so what I'm going to do, this graph I'm going to still use it, and also, so we are not going to delete it. Alright, and then all these other ones we're going to keep them. So I'm going to write everything that is going to follow you. So now let's do 12.10. Okay, now why I was saying linear programming is simple. Now think of this one. Now it says the cost of hiring a red bus is 600 rand for the day, and the cost of hiring a blue bus is 300 rand for the day. Write down the total transport cost. You don't know the transport cost, right? So just represent the C. Transport cost. Okay. How many buses of red are we going to hire? You don't know. So it's going to be 600 per bus times X. I don't know, né? Plus, how about blue buses? 300X. So this is the expression for the cost. Done? That's why I say write down the cost of the total transport cost. Okay.
Excuse me, sir. Yes. Why do we have two values where else we only calculating for one bus? We need the values for one bus, isn't it?
Okay. Now listen here. We are not told that how much they have to hire this. They're just saying the total cost of hiring the bus. Now we are going to hire red buses and blue buses. How many? We don't know. That's what we want to ascertain.
Okay, so why is 300x instead of 1?
Sorry, I made a mistake. Why? This shows that you are following. Because I made a mistake, I was supposed to put why. 300, because remember there is 300 for blue bus, and then 600 for red bus. So whatever, even if we were to hire, let's say 10 here, we're going to say 600 times 10, 300 times 10. That's the cost of transport. That's it. Okay. This is pretty simple and straightforward. Okay.
So this
is the answer. This is the answer.
Okay.
Now, 12.41, it says determine all possible values of x and y so that the cost will be minimum. Alright. Now, let's come to our diagram here. This is where you need to think. Okay. It says determine all possible values of x and y so that the cost will be minimum, will be low, will be kept low. So this is the feasible region. Okay, we are saying we need to operate in this region. Whatever that we're going to do, operate here. Now the minimum point, we have to choose. This is the minimum point. This one is not minimum point. This is the minimum points that we need to choose. Whether we're going to choose the red buses, we have to choose them. They should be within this line. This is the minimum. And then our blue buses, we should also choose like as we have done for the red buses. So if we say, let's say we need 10 red, we are going to have 0 of blue. Okay? That's the minimum point. Remember, it says determine all possible. So we are going to check on this line. Unfortunately, here it doesn't present well. But we are going to have, like already, we are going to have, let me say, 12.41 here. Let me label the points there, all possible points. So we are going to have, first of all, we have got 6 here, which is going to be there. So if we choose 6 red, you are going also to choose 8 blue. Okay. 6 red, 8 blue, 1 point. Now 7. That's why I said unfortunately. So 7, we don't. If it was nice, we're going to see where there's going to be with what there. And then 8, we're going to see. But one point again that you know, like we are going to have 10 and 0. 10 and 0. But if you present it nicely, we're going to have these points 6, 7, and 7, 6, and then 8, 4, and then 9, 2. So these are possible points that we need to have 6 red and 8 blue, which means 6 buses that are red and 8 that are blue. That's it. Those are the all possible values of x that the cost will be minimum. Why we choose this criteria here, where the cost will be minimum? Okay. This is minimum. If you wanted maximum, we're going to come to this one. Okay. Right. That's the reason. So the minimum, we're going to use all the points on this line, and then we're done. So those are the points that we have. But now it says calculate the minimum cost of hiring the bus. Remember the cost of hiring the bus. We have 6876. Now let's come in. The minimum cost of hiring the bus. Let's look at first point 68. So minimum cost will be 600 times 6 plus 300 times 8. What are we going to have? We are looking at the minimum cost of hiring. What is that?
6,000. 6,000.
Yes, 6,000. So all those points, try to put them. We've got 680, 87, 76. Put them in this function. You're going to get 6,000, 6,000, 6,000, which confirms for sure that all those points are minimum points. So we just put all those points that we have 68, 76, 84, 92, 10, 0 in this. But now on 10, like if it's 10, 0, which means our x is now 10. So 6,000 times 10, 6,000, this one is 0. So you continue to do for each and every point, for each minimum point, so that we get all the marks. Okay? So that's what you need to do. For each and every point, continue. You still get 6,000, 6,000, 6,000 for each. Right? Any question?
So if they are asking for all possible values of x, like you have to write all of them.
All possible value of
X, of which they're going to give you the minimum.
You know, here, yes, we have got these options. We are saying we have got 500 students after we've done our assessment, whatever, physical region. We are saying we can either take 6 red and 8 blue, or 7 and 6, 8 and 4, alright, all those points. But now we want to achieve the minimum point. That's the point that we are saying we need. But now, I think your question will be answered when we come to 12.5. Let's just do 12.5 and then we will see if you still have the same question. Now on 12.5, it says, if exactly 12 bus drivers are to be used, determine the number of each type of bus which the school will now be able still need to ensure minimum cost. Alright, remember we've got this range. So, but we have 12 drivers. Let's take 6 and 8. What does it give you? 14. So we can't have 6 versus 8. This portion is out of question. 7 and 6? Out of question. 8, 4?
12.
That's it. 9, 2? 10, 0?
10.
But we have 12, so we are going to choose this point.
Okay.
So that's the point that is going to. So we're going to have 8 red buses and 4 blue buses, so that we have 12 drivers. That's the whole point of linear programming, because you want to determine, okay, how are we going to do this? All right. So that's how we have done it. Make sure you understand the constraints. I want to put them, once you're done, present them on the graph. It's very simple, linear, feasible region. Use anybody to say this is greater, and then you do like this. From there, you play around with that. If they say maximum point, you're going to come in. Minimum, yeah. Because this is minimum. Alright. And then all these points that are here, if you were to draw graphically nicely on the book, you're going to get those points. So after all possible values of x, y, so that the cost will be minimum. Now calculate the minimum cost of hiring. So just say, okay, we may have 6. Now inputting all the costs function. And then you get that it's 6,000. That's the minimum cost that we can have for hiring. So even when you're making a budget, you know we need to keep 6,000 in our pocket or more, because that's the minimum point. And then we say we've got 12 drivers. How many are we going to choose? If you're 10, we're going to choose this one. 10 but in this one, 0. Or that's it all. If you had 14 drivers,
6 and 8.
that's it. So this is what determines, say, we do this or we do this. So is linear programming tough?
No.
It's more of common sense. Alright, so this marks the end of our paper 1. So go through them again, through them again, through them again, through them again, until you're done. Practice makes perfect.